Okay, hello everybody. This is Dr. S here, and I'm going to present to you exercise 1.5, question 8. All right, let's begin. See if I can make this a little bigger. Here's the question. Consider a triangle with vertices A, B, and C, and if we have this equality, if the length of these two sides are equal, then we have to show that the angles at A and C have the same magnitude. Okay. So what we have to do here, folks, is we have to write a proof. All right, so when we have to write a proof, the first question that almost always comes to mind is, well, which proof technique should we use? You may have seen a few different techniques by now. There's direct proof, the most straightforward, hence the name direct proof. But you can also be a little fancy and do proof by contradiction. That's a good way to prove a negative. Well, that's not what we're trying to do here. Proof by contraposition, fancy. I don't think that's needed. Mathematical induction, that's not going to be needed here. So I say, let's try direct proof. This is usually often the first go-to. Okay, I'm not going to use anything fancier unless I decide that I have to. Okay, let's just do a direct proof. All right. Well, I thought I would give you some tips for how I do direct proofs, if this helps you before we begin. You can more or less break it down into 5 steps. Here's how I do it. Step 1, if helpful, draw a picture. Okay, I'm going to do that because we're dealing with a triangle. I can draw a picture of a triangle. And then you'll see me give important things names. Okay, so make it easier to refer to them later. Okay, I'm going to give the angles in this triangle names just to make it easy to talk about. Okay, and that's quite helpful. Step 2 then, state what is given in the problem. Okay, there's some information in the problem. We know that two sides are equal in length. I'll do that. State what you want to show, okay, or in other words, what you're required to prove. Either way you want to phrase that's the same. That's just you want to have a goal in mind. Okay, you want to have a goal in mind. And I'll show you how that works. Think of a strategy. Here's the hard part. Think of a strategy to accomplish 3 using 1 and 2, and then 5 trying out your strategy, okay? Try your strategy out. There's no one right way to do proofs. That's what makes proofs fun in some ways, but also challenging in some ways. So don't be afraid of failing. If you fail, try again. Try a different strategy. Ask for help if you want. Those are my 5 steps, okay? Those are my tips for you. I'll go through these 5 with you now in problem 8. Okay, so, we've got the triangle with 3 vertices. 2 of the side lengths are the same. Step 1, draw a picture and give names, okay? Well, I'm going to draw a picture. I've got a triangle with 3 vertices, A, B, and C. Okay. What else do I know? I know that this length, which is the norm of B minus A, or norm of A minus B if you prefer, same quantity. I know that this has length C minus B, or B minus C if you prefer. Actually, let me be consistent with the problem and say B minus C. Not that it matters. Then finally, this length, we'll call it C minus A, or you can call it the norm of A minus C, of course. Okay, I'm going to give names. Let alpha make sense. Let alpha be the magnitude. Let alpha be the magnitude of the angle at A. Okay, so that's going to be alpha. Okay, let alpha be the magnitude of the angle at A. Okay, I'm going to cheat, and I'm going to copy and paste, so I don't have to write this out 3 times. But we've got 3 angles, so let beta be the angle at B. Call that beta, that makes sense. And then gamma, we can make that the magnitude of the angle at C. So there you go. I've given the angles names, so they're easy to refer to, and I've got a nice picture here, which helps me visualize what's going on. Okay, that's step 1. Draw a picture if it helps you. I think it does in this case. And give things names, important things names. What's important here? Well, the magnitude of the angles. Okay, now I can just call them alpha, beta, gamma, and it's just easier. Okay. Step 2, state what's given. Well, we have a triangle. With vertices A, B, and C. And it's given that the length of this side connecting A and B is equal to the length of the side connecting B and C. That's what's given. Okay, so we have to use that. We have to use that. Unless, of course, it's a very poorly phrased question. That's not the case here. Okay, if it's not a poorly phrased question, we have to use what's given. Okay, write what you want to show. Well, that's pretty simple now. We want to show that the angle at A, now I can just call it alpha, is equal to the angle at C. Now I can just call it gamma. Much easier now. Cool. All right. So far, so good. Step 4 then is we have to develop a strategy. I'll let you know what I have in mind. Well, I know we're interested in 2 angles, alpha and gamma. Okay, we want to show that they're equal. So we have 2 angles that we're at least interested in. And we also have some useful info, don't we? We know that the lengths of these 2 sides are the same. Okay, so is there a tool I can use? You know, tools can be definitions. The cosine law always starts off like the Pythagorean theorem, actually. That's how I remember this, okay? Pythagorean theorem. But then you have to keep going, because we don't necessarily have a right angle. And then what I do is I can kind of copy and paste these sides for this last term, okay? B minus A, but I don't square it now, times C minus A, I don't square it now, times cosine of the angle we're interested in. We're interested in alpha right now, okay? There we go. There's the cosine law. But I think we can simplify this. I think we can simplify this because, well, I know something. I know this length equals this length. So I think I can cancel some stuff out here. Okay. Now you're going to develop your own style, folks. Your own personal style. My personal style is I like to be pretty thorough. I don't like to miss any small steps. What I'm going to do here is I'm just going to change the B minus C here to a B minus A. And I could probably do this a little faster, but I don't like to do that. I like to be very thorough, so I don't have any gaps in logic. I don't make any small mistakes and ruin my proof, okay? I'm a very careful person when I do this, okay? All I did there was change B minus C to B minus A, okay? Or I should say the norm of B minus C to the norm of B minus A. We know those quantities are equal. Okay, and now just copy and paste the rest here. Okay, now look at this. These cancel out. Okay, just like we're in school again, these cancel out. I'm going to go ahead and move this term to the other side. And I can say thus, we get, if I move that to the other side, here's what I get. sorry, not cosine yet, c minus a, cosine of alpha. And what is left there? It looks like just c minus a squared, huh? All right. I think I can simplify even further. I think I can solve for cosine of alpha there. So hence cosine of alpha is equal to, if I divide both sides by this piece, I get some cancellation with the c minus l. I should say the norm of c minus a. But I still have one norm of c minus a left up top. The 2 goes onto the bottom, and I have a b minus a, norm of b minus a, that is, on the bottom. That's cosine of alpha, folks. And that's good. I think I can follow my strategy in doing this again for gamma and then see if we can compare cosine of alpha with cosine of gamma. Okay, let's see if that helps. If it doesn't, no problem. We'll try something else, but I think this will work. By the cosine law for gamma. What do we have? So gamma again was the angle at C. Gamma again was the angle at C. So the cosine law, at the very beginning, it's not going to involve a C. It's b minus a squared, or a minus b, of course. Okay, that's how I remember that. The first one does not involve C because gamma is the angle at C. Okay, but then we have the other two sides. The other two sides do involve C. The other two sides do involve C. Don't let me forget to square. Start off like the Pythagorean theorem, and then don't forget to finish with the two sides that do involve C, because gamma is the angle at C. Okay? What do we know? Since b minus a in norm is equal to b minus c in norm, we have, now I'm going to do the same thing. I'm going to change b minus c, now that's right here, to b minus a, okay, to b minus a, and I think that's all I'm going to do. It just pops up again here, b minus c, there we go. I change it to b minus a. Those quantities are equal. That's all I did. Okay, and just like before, why do I do that? Well, so I can simplify things. I can cancel things out. Okay, so what do we know? Just like before, I'm going to move this cosine term to the other side. Just like before, I still have norm of c minus a squared on the right side, and just like before, I'm going to solve for the cosine term. Okay, the cosine expression, cosine of gamma is equal to, again, I get a fraction. Again, I just get norm of c minus a at the top, and here I get b minus a, 2 times norm of b minus a. And I think that's exactly what I had for cosine of alpha, if I remember. Yeah, I can probably get them in the same screen. Cosine of alpha, cosine of gamma, gosh, they're the same thing. Cool. So let's write that down. Therefore, cosine of alpha equals cosine of gamma. All right. At this stage, it might be tempting to write, okay, well, therefore, alpha equals gamma, but we know better than that in general. This does not imply alpha equals gamma in general, right? Cosine of 0 is 1. Cosine of 2 pi is 1, but that doesn't imply that 0 equals 2 pi. So we have a little bit of work yet to do. Well, I could just say this. This I can do fairly easily. I can just, actually very easily, I can just take our cosine of both sides. Right? Isn't that the natural thing to do? Try to get these cosines to go away. Well, we can take arc cosine of both sides. And then now we have to ask ourselves, do arc cosine and cosine cancel out? And in general, not always. But if the angle, alpha or gamma in this case, if it's between 0 and pi, then it will cancel. Things will cancel out. So here's where definition comes in. By definition, and no, I don't know the exact number. I'm not going to say by definition, number. I don't have that memorized, and you don't have to. Just say by definition, we have, since these are angles in a triangle, we know that by definition they are angles in this interval 0 to pi. Okay, this is in our course notes in our textbook. Okay, well, that's good. Hence, I have alpha equals gamma. Okay, let me give a reason. We should always give reasons, unless it's very, very, very basic, something like adding, adding or multiplying. This is not super basic, so let me give a reason. Arc cosine of cosine of theta just equals theta whenever theta is in the right interval, and that right interval is 0 to pi. Okay. There you go. I like to end my proofs with a little box, just to let who's ever reading it know this is the end. And once you show what you wanted to show, folks, you can stop. You are done. Okay, we wanted to show alpha equals gamma. That's exactly what we did. Okay, so I'm going to stop here. Shout if you have any questions. Okay, I'm on Discord. I'm on email. And let me know if I can help you further. Otherwise, enjoy the rest of your day. Take care. Bye-bye.